Hey there, what do you know about thermodynamics? Don't know? Well, I am here to brief you about the thermodynamics. First of all, I want to greet you. Very nice to see me in front to talk about the thermodynamics. Well, sit down, relax and enjoy my lecture. Okay, first of all, I will start with a simple example of the second law of thermodynamics. See, as you can see in my drawing, there are a cup of tea with a temperature 60 Celsius put in the surrounding air, and logical thinking, the cup of tea never get be hotter. Indeed, it could be cooler. The temperature will drop to the something temperature that is never exceed of the 16 Celsius, like 40 Celsius, 30 Celsius and drop. There you can see this is the principle of the second law of thermodynamics. The heat flow from heat to cold, and the cold will never flow to the heat. Okay, I will proceed to another example to make you more understand about the second law of thermodynamics. The first of all, okay, now I will brief you about an example of the second law of thermodynamics. Heat engine. What do you know about heat engine? This is not an ordinary engine that runs your car, run your motorcycle. No, this is visually engine that operate in a cycle. So you can see it is boiler as a source, condenser as a sink, turbine for the workout, and the fan for the work in. The fan is act as a pump to pump the fluid in the cycle. First of all, I will review the generally about the heat engine. The basic principle working of the heat engine is first from this, where the boiler receives a high heat temperature such as a furnace, boiler, solar energy, nuclear reactor. Second, turbine. this usually convert the heat produced from here to work that can spin the turbine, as you can see, to work out. So from there, it's transferred, it's it, and the work is done. Thirdly, the condenser. The function is to reject the remaining waste heat to lower the temperature sink, and then the heat out. And the fourth is the pump. The pump function is to operate this piston engine in a cycle. Okay? I bet you are wondering where this heat engine is applied. Well, you can see the heat engine is applied in the air conditioner. Okay? Never mind, sit back. I will show you about the air conditioner working. Okay, now I will explain to you about the uses of the heat engine in a real world. So exactly application of the heat engine. In this nowadays, there are many examples that use the heat engine principle. But I pick one that you can understand easy, the power plant. These are the basically working principle in the power plant you can see in the world. First, the furnace. The furnace provided large heat such as fossil fuels, nuclear plant, and then they transfer the heat to the generator. When the steam they produce from this transfer into this, move the turbine inside this, attach to the generator that can produce electricity. Then the result of the moving the generator transfer into the condenser and then transfer back into the pump to maintain the operation is in the cycle process. Now you see the process of heat engine, the application of heat engine in this real world. Okay, we move to the next part. The next part I want to talk about to you is the Kelvin-Planck statement. The Kelvin-Planck statement states that it is impossible for any device that operates on a cycle to receive heat from a single reservoir and produce a net amount of work. In the simple work, such as the cold temperature never flow to the hot temperature. simple work. To do the cold temperature, to flow the heat from cold to hot, we need a special device called as refrigerator. The refrigerator is a sample of the working principle of the Kelvin flag statement. I will draw to you to make you more understand about on this topic. Okay, as you can see, this is the diagram of the work principle based on the Kelvin flag statement. Note that the arrow of the flow of the cycle is reverse to the flow of the second law of thermodynamics. From starting, the refrigerator space, the refrigerator is placed in here, and then it absorbs the heat in the space to maintain at the low temperature, then flow to the compressor, and then flow back to the boiler to transfer the heat to the area outside. And then transfer back to the valve, and so on, the cycle continue. There are one more devices that use based on the same principle, heat pump. Okay, I will show you about the heat pump.